Hello everyone, my name is Malte Junge. I'm from the chair Design Computation at RWTH Aachen University, where we are currently researching the integration of parametric product catalogs in IFC. So, to start with, we have a problem with MEP product data in our industry currently. So imagine there's an architect and an MEP planner, and they are trying to find the right heat pump to put in their building project. So the architect gives the current state of the building model to the MEP planner. Then the MEP planner does some calculations, comes up with a list of requirements, and approaches a heat pump manufacturer with that data. And then the manufacturer makes a proposal for a possible product to use. And then the MEP planner integrates that into their system, passes the information on to the architect. You see, all this takes a lot of time. And while they're doing that, they're passing on product information, product data. And they're doing that in a variety of different file formats, such as Revit families, or just DWG files, or lots of plain old PDF, all those data sheets. And now, of course, there's going to be design changes. And there's multiple manufacturers that we're talking to, and they have uncountable product variants. And so we get these time-consuming information loops because the data that we're passing around is rather static and not flexible enough to account for this process. And so we have to send out new files, new PDFs, new Revit families over and over again. And so it just becomes this big mess. And that's what we're trying to tidy up a bit here by bringing product data formats and building models closer together. And we want to do that by integrating parametric behavior and information linking in IFC. Let's look at an example. So we have a heat pump here, and we have its data sheet. And this data sheet is full of input values, which are static. And then we have output values, which are supposed to be dynamically calculated from those input values. For example, if we calculate heating output, we have a lot of these input values, and then we take some of those, and we generate an output value from them, and then we take that output value and some more input values, and then we can calculate the heating output. And then we can take that heating output and use it to calculate other output values, for example, the coefficient of performance. And the manufacturer then in the product data sheet specifies how to do that by giving us some formulas of how to calculate these values. All right, there is already a data format, a digital format that is able to map these complex dependencies. It's called the VDI 3805. It's a German industry standard for product data exchange in building services. And it does a lot of the things that we need. It is machine readable. It has a parametric geometry core. It supports this calculation of dependent values dynamically. And it does that by mapping all these dependent values in a hierarchical tree structure so that we can keep track of which value is needed to calculate what other value. The problem with this format is it's limited in scope to the German AEC sector. It's not very well known outside of Germany, I believe. And it's also quite old. So it's just the integration with our current software tools is severely lacking. And what we're trying to do now is take the parts of that format that we really like, leave out the rest, and come up with a new format, not with a completely new format, but we're just going to put those parts into IFC and develop a new international standard that has all these features. And in order to do that, there's a lot of things, of course, we have to do and implement. I'm going to talk specifically about two of those today, which is linking those values and calculating them dynamically. So how can we map all this interdependency in IFC? First, we're going to look at some tables. So we have some product data here, and as I said, it's hierarchical. So it's an overarching category. It has a few subcategories, and all those categories can be mapped as a table. So these are all tables. What do those tables look like? Well, we have properties. Each column is a property, and every field in that column represents one value that that property could take by definition of the manufacturer. And so then we have a row from that table, and this is now one valid property combination in that property set. So that's one specification that the manufacturer can allow to exist. And now if we take one of those valid rows from each table and we link them together, that is one heat pump configuration that can be delivered, that can exist in the real world. And so now we have to figure out, how do we link these tables? Well, one thing that we can do is, let's look at an example. We have a table, or just a single row here for simplicity's sake. We have a row of input values and a row of output values that we want to link. So we add a key column at the start of those tables, and then we can add a reference column at the end of one of those tables, and this reference field then can reference the row from the other table. And so this is a very straightforward way of linking those two rows together and saying, okay, these output values belong to those input values, but of course we're not yet calculating anything. This is still static. We're just saying these values make those values. It has also another problem with that, and this is, I think I'll go back quickly. We're creating a lot of redundant data doing it like this, because if we just change one of those values, we have to make a whole nother table row with just one value changed, and then add another reference in the other table, even though all the other values stayed the same. And so we just have a repeating data in one product data catalog that we examined. There were over 20,000 entries of just redundant data, because just one value means you have to repeat everything. And so what we try to do now is say, all of those rows have a UUID, and they're just there for data storage now in our IFC file, and we reference them with an external reference. So for example, we could send out the product data catalog as a container with a JSON file that then references those two table rows together. Or those references could be in the manufacturer system available online. And so they could also be updatable. And now we have talked about different methods of linking those values. Now we can start actually calculating them dynamically. And so we can do that either also in a container file or in the manufacturer system by implementing those calculation formulas there, or we can do it directly in our IFC files by using JavaScript code in the file that then gets executed. It references those values. It knows which input values are connected to which output values, and we can finally calculate them dynamically without having all this data in our file all the time. And so, to conclude, what we're doing here is we propose a method of linking and calculating dependent property values in IFC, and we're doing that to map extensive and complex product data. And we're doing this because we want to standardize the information exchange of product data in our industry, and we want to integrate parametric behavior into IFC. Of course, there's still some work left to do. This is a work in progress. We are just getting started implementing product geometry. So we have all these values mapped out and linked here in Bonsai in Blender. And now we want to start being able to have the geometry of a proxy element representing the installation dimensions change parametrically when we change those input values. And then, of course, our example case or use case is just a heat pump. We still have to contextualize it with other MEP products in the big building service systems. And also we have to think about industry implementation. So we have to scale this up to these full-scale catalogs. We have to think about things like best practices, workflows, documentation, and that's what we're going to do in the coming months. I thank you very much for listening. If you have questions, let me know now or send me an email.